Okay. Okay, so Timothy had a question that is really crucial and important, and I'm going to base on that. So we are interested in running a regression statistic of age on tenure. When someone says something on something, the interest is in trying to see whether maybe one variable has an effect on the other variable. So we want to see whether age has an effect on the time someone spends with a telecom company. And so what that means is that now we are going to be able to go back and run the regression statistic, which we normally call the line of best fit. We say that the line of best fit has the y and x variable. The y variable is the dependent. The x variable is the independent. The independent variable is the one that affects the dependent. So it is the one that has the own factor. So whenever you see age on tenure, it means that you want to see how age affects tenure, meaning you want to see whether tenure depends. So in this particular example, age is our x variable, and then tenure is a y variable. So the first thing you do for any regression is you have to make sure that you really understand the x and then the y, okay? Because that when we get to the actual running of the regression, they're going to ask you for what is your dependent, what is your independent. The y is the dependent. In our demand function, it is the one we have as a QD. When we say QD is equal to A minus B, P. So this one here is Y, what we call the dependent, because we are saying that demand depends on the price, and then the price, of course, is our independent. So this is what we are going to do. I hope you have the data with you. We are going to go into our data. It is age on tenure. Pick that two. Okay. Just a moment, it's not active. Just give me a moment for my Excel to get active. This one is active. Okay. So let me first make sure that my Excel is active, because cancel. Okay. Let me first make sure that my Excel is active. Okay. Please hold on. My Excel is inactive. I'm trying to check that it's active and we continue. What answer should I give to Mr. Ojambo? Mr. Ojambo is saying that I'm requesting that you send that Excel work on our WhatsApp. Don't you have the work? Because I think it's the first thing I sent. Timothy, didn't you share the work?
I shared it.
Okay, so Mr. Ojambo Robert, the work was shared in our first class. Maybe get to the class representative, get in touch with him to kindly share the work with you, but it is the first thing we did. Please hold on to make sure that my Excel is active. It's still giving me some issues. He's going to share it again. It's not closing, it's not opening. Okay. Please hold on a minute. I'm trying to make sure that I open something that we can work with. Okay. Okay. Okay, now let me reopen it again and I see whether it will be active. I don't understand why it is. Okay. Here we are. Sorry for that small mishap. You know, these things can happen. Actually thought it was okay, so let me share my screen now. My Excel is now active and entire screen. So we are interested in ascertaining whether age affects tenure, the time someone spends with a telecom company. And so we are going to run what we call a regression statistic. Remember, we already ran the correlations. We did the scatter plots. We got the correlation coefficient. So we already have an idea on the kind of relationship, but we want to see what we call the magnitude or the net effect. So what we do is I hope Timothy has reshared the data because he promised. For some of us who didn't have the data, please try to get the information. Now, what we do is we come and select, like I keep telling you, whenever you're dealing with analysis of data, always keep your original data intact and work within other sheets for analysis in Excel. If you're dealing with data, we normally emphasize that you have a do file so that you don't keep on changing your original data. And of course, you'll also have an output file when you're dealing with SPSS that can still store your commands or store what you've ideally worked with. So the first thing we do is we are going to come and copy the two variables of interest. The good thing with these variables is that this time around they are next to each other, but I keep telling that even if they're not next to each other, the moment you highlight the entire column, because this is the original data, there is nothing down. So you just, the moment you see that big arrow that points down, you simply go ahead and make your selection in such a manner, and then you click on the control button. If the variables are not next to each other, it's what I'm explaining, and then you click the next variable, and then you just simply copy, Control C or right click and copy. But this time around the variables are next to each other, so we shall see these the same. We shall highlight both those variables and Control C or copy. I hope people have managed to copy. Have we managed to copy?
Yes.
So we shall add another sheet. As you can see, we have many sheets in our workbook. These many sheets are all having the different analyses we've run since we started our class. So we shall add a sheet. We shall click on adding a new sheet. On the plus, some people have add sheet. And then we shall simply paste or Control V. And then we are going to rename this sheet as tenure. We have tenure age already. We shall rename it as tenure age. Okay, rename it as tenure age reg to mean regression. Rename it as tenure age reg because you already have tenure age for the relationship. So rename it as tenure age regression. We can as well work here, but let's work in a new sheet. Have you managed to rename? Yes?
Yes.
So let me have at least 1 or 2 active people that are going to keep on. Maybe we have the interaction moving so that I can be able to ascertain that we're moving together. Now, the moment you ascertain, of course, the view is quite small because I'd kind of put it at 100, but I can zoom in and out for you to be able to have either a bigger or smaller view. Now, this is our data. So our interest is in running the regression statistic, which is running the line of what we call best what? Best fit. So we are interested in running a line that says that y is equal to mx plus c. That's our interest. Our y is the tenure, our x is the age. So let's come to data. Data, we are there, right?
Yes.
Data analysis. Data analysis. Are we there?
Yes.
So this dialog box pops out. These are some of the statistical tools we can use for data analysis. There are quite many others when you come to formulas, but these are the, let me say, the core ones in the statistics of Excel. So you come and scroll through to look for the one you need. These are the inferential ones, mainly. So we are looking for the regression. So we come and look for the regression, which is here. You click on it. You scroll through all the tools available till when you find the one you need. This time around, we need regression. Last time we used the correlation. The other time we used descriptives. So you click on the regression and then you say, okay. Now, when you say, okay, I want us to really be together at this point because it's very important for us to be together at this point. The first thing they ask when this dialog box pops up is, what is the Y range? The Y range is the dependent. It's very, very important for you to be able to distinguish between what depends on the other. The one they call the Y is the dependent. It is the one we normally put on the x-axis if you're going to get the line of best fit. So you just come in here. Like I keep emphasizing, it's very important that when you're picking this data, you pick the labels as well. So you come, put your pointer or your cursor in that cell. Then you come and select your data. You come and select your data from the label to the last one. If you don't want to do the selection like that, I told you that you can just know that this data is in cell A, in column A, from row 1 to row 20. So you can just come and put from A1 to A20, and then you fix it. Fixing it is when we put the dollar signs, to mean that the values are going to be constant. The value in each cell is going to be constant, meaning it doesn't change. Otherwise, if you feel you have issues with that, put your pointer in that cell, select with the label as well from the start to the end. When you know you're done with the end, release. Come to the X, do the same, select the label as well. Don't make a mistake of selecting the label for Y and then not selecting the label for X, because it will still tell you that there are issues. Please make sure that when you select the labels, you select. If you don't want to select the labels, it's also okay. But like I keep telling you, when you select the labels, that table that will pop out, as we are going to see, will have the name that this is age, this is tenure, which makes it easy for us to even comprehend and explain. Okay, so after selecting your data, the next thing you do is you click on labels, check or tick in that box that has labels. The reason why we check in that box or we tick in that box is because when we are selecting our data, we selected these labels as well. We selected the label tenure, we selected the label age, meaning it is very, very important for us to check that we selected the labels. And this one, you realize that if you recall your QM, you studied something in probability. You studied something to do with the confidence level. Now, every time you're doing analysis of any kind of data, because you're mainly using sample data, many times, actually all the times, we normally use sample data. So because you're using sample data, you want to attach a probability to your analysis. You want to tell someone that I am maybe 90% sure of my results, or 95% sure of my results, or 99%. Of course, you can't be 100% because you're using a sample. But at least the common ones are 90, 95, and 99. but the most common one is the 90, 95 level of confidence. So if you're interested in getting the confidence levels, the confidence interval estimates for your coefficients of the regression, then you can check this. Else, you can leave it unchecked. But we shall check it. Take note. You can have 90, you can have 99. They are the most common ones. And also, you can be able to leave it unchecked if you feel like you don't need anything to do with the confidence levels. But let's check it and put it at 95. I hope we are together up to that point, are we?
Yes, we are together.
Okay, so click on output range. Because we have our sheet ready, we are not going to go to a new worksheet. So click on output range. I want to emphasize this again because it gives us hard time. The moment you click on the output range, make sure you click in the adjacent cell. Make sure you click in the adjacent cell so that you have the opportunity to select where you want your output to be. So the moment you click on the output range, click in the adjacent cell, and then click in any empty cell in your worksheet. Click in any empty cell in your worksheet. You can click in C1, D1, you can click in J4, but let me put mine in D2. You can click in any empty cell. So the moment you click in that empty cell, it's going to show here, and leave all the other things out at the moment, and then you say, okay. Have you managed to do that?
Yes.
Yes.
Okay, so this is the same result that we got. It's here. And I'm going to explain these things one by one, especially for those who are interested in them. So Excel begins by giving us its results. The first one is what we call a multiple R. This multiple R is simply our correlation coefficient. In Excel, when you see multiple R after a regression, it's a correlation coefficient. So this correlation coefficient is equal to 0.713, which is a strong relationship, and the relationship is actually positive. I guess we are all okay with that one, right? Yeah?
Yes. Yes.
Then this one here is what they call the R square. This is what we understand as the goodness of fit or coefficient of determination. So this one here is normally when you square this, when you square the correlation coefficient, you end up with this value here of the R square. And what does it do? The R square, I want to explain it so that you can be able to appreciate. It tells you the proportion the independent variable, what we understand as the X variable, explains in the dependent. It's more like when I say that the price of a good affects the quantity demanded of a good. So someone will say, is it a really good fit? Can you say that the price has a very high explanatory power? Ideally meaning that, can you say that price strongly affects or strongly explains the quantity demanded? So that is when we try to, we bring in what we call the goodness of fit or coefficient of determination, what we call the R squared. Of course, it is normally in between 0 and 1, and we normally put it in percentages. So you're going to see 0.508, which is about 50.8%. Of course, they'll tell you that values of R squared that are above 80% are really good values. It would mean that the independent variable explains 80%. That's kind of huge, meaning it leaves out only 20%, but the 80 is explained by it, meaning the independent variable has a very high explanatory power on the dependent variable. So this value here is what we call the goodness of fit. In percentages, it is 51% or 50.8%. And we can say that this 50.8% means that age is the independent, explains 50.8% of the changes of the variations we see in tenure. So age explains 50.8, which means that the remainder, which is about the remaining percentage, which is about
49.2.
which is about 49.2, is explained by other variables, but not age. So it means that age explains, but its level of explanation is quite, like, it's not like, so it doesn't have a high explanatory power, though it explains, but still the other variables that can explain that dependent, which is tenure, that can affect tenure, also take up a big percentage, which is 49, but age explains 50.8. Have you got that? So it's normally values that are above 75%, 80, that are taken as variables that have high explanatory power. That is why you're going to realize that when we start now decision making, it's like when they're making decisions on maybe policies, they normally do what they call prioritization. You're going to realize that your performance could be affected by the rooms, by the lecturers, by the course units, by maybe where you reside. And then you realize that when interventions are coming, they're like, no, let us start by making sure that the lecturers are okay. Because in terms of explanatory power, I want to give you how relevant this is. In terms of explanatory power, you could find that the lecturer explains a big proportion as compared to where a student resides. So they're like, a lecturer has a bigger explanatory power than where a student resides. So let's first make sure that we work on this, and then we shall. So this is the R squared. Now this one, the one they call the adjusted R squared, it is the one that normally adjusts for what you call the degrees of freedom. I believe you've heard of that term in your variances, in your QM. What normally happens is that this one here, we use it to explain, it does the same thing as this. It really explains the goodness of it, but for it, it adjusts for the number of independent variables in the model, which ideally means that if you're looking at a model, any kind of model, and in that model, you're having more than one independent variable, then that means that this is when this becomes applicable. Otherwise, if you're looking at a model where you have only one independent, like here we have only age, that's simple linear regression, then we only use R squared. But if we had a model that was looking at age and maybe income on tenure, those are two independents, then we would use the adjusted, because this one adjusts for the degrees of freedom as a result of having more than one independent variable. So ideally, meaning that if you're looking at simple linear regression, simple 1x, 1y, always based on the R squared to explain the goodness of fit. They do the same thing. Else, if you're looking at a regression whereby the dependent variable will always be 1, you have your 1y, and then the independents are more than 1. You have age, you have income, you have sex, you have, as long as the independents are more than 1, this is when this becomes important. So when you're explaining this, for example, if we had our independents as age and income, I would say that 48% of the changes we see in tenure are explained by age and income, meaning when you combine those two, adjust their degrees of freedom, or for the number, how many they are in the model, this is what they explain. So every time you have one dependent, please explain the goodness of fit using this. Else, if the independents are more than 1, you explain it using that. Then, of course, we have the standard error. In regressions, we normally have something called the error term. So this standard error is basically the estimate of the standard deviation of the error. It is not the same as the one we had in our descriptive statistics, take note, but it is basically the standard deviation of that error. And it gives us ideally the level of precision for the regression coefficients, as we are going to see. So basically, we just kind of compare it with the coefficient that we have, and then we can be able to see, for example, here the standard error is 15, the coefficient is a 1.5. We can be able to see that the value of the coefficient is quite small. So what I can say is that this one here is what basically helps us to be able to compute the residues to be able to see whether the heteroscedasticity, collinearity, those aspects of hetero especially, and autocorrelation, to be able to see whether there is that kind of understanding of constants. But it's basically an estimate of the standard deviation of the error or residual term here. Because remember, when we are writing our models, we normally say that y is equal to, let me say QD is equal to A minus BP, and then we add plus the errors, meaning there are other factors that could affect. So because here we are focusing only on age, those other factors are taken up by that error. So that error can be computed, and then this is the standard deviation of that error. So normally we don't explain or talk about this, and of course these are the observations. So the key things are this and that, if you're having one independent, one dependent. This is the ANOVA. This is what someone wanted us to discuss. How relevant is this table? Now, this table kind of helps you to be able to see whether your model is significant. It helps you to really understand whether the model you've run is actually significant or not. You're going to realize that for us to be able to get the R squared, that R squared value there, we get the sums of squares for the regression divided by the total. For example, when I get this divided by the sum of square, I'm going to be able to get that R squared. Now, how relevant is this ANOVA table? ANOVA is basically the table we use in these regressions to be able to see or to be able to conclude whether the model we are running is a good model, relevant model, or not. How do we ascertain that? In this ANOVA table, we have something called a source. This is a source of variation. The model we said we are running is a model called, please, you can be steady a bit here, is a model called that tenure is equal to A plus B age, because we are saying that age is our independent variable. So when we are running such a model, like this one we are having here, the understanding is that this one here is the regression, okay? This A plus BX is a regression. Then, of course, we can recall that we had errors, something we used to say E, the EI. This EI here is something that tells us that tenure can depend on age plus other variables, which we normally call the residual variables. So that at the time of now, the actual estimate, because of the limitations of the data, instead of running tenure on age and other variables, for us, we are removing other variables and we are focusing on age. So this is what happens. The source of variation in tenure, because tenure is dependent, can arise, can come from this here, which is the regression, the constant and the age. That source can also arise from the error, these other variables that we've not looked at that could affect tenure, because you could think it is age that affects tenure, and then someone tells you, me it is income, me it is my sex. So these other variables, that is what they call the residue. The residue is the same as synonymous to error. And then this is the total variation, ideally meaning that when you look at this tenure data, you can see that the values are not the same. So this is the total variation, irrespective of whether age is there or it isn't there, or any other variable is there. So the interest you're having whenever you're looking at this regression, this ANOVA table in this regression, is you want to be able to ascertain whether the regression is significant, because you want to be able to make a conclusion that actually, when I look at my tenure from A to age, which we call the regression, it is actually significant, which means that I can be able to sit down and start making conclusions as a policymaker that basing on my regression model, which was significant, age is a very important factor. So we need to really be very careful when we are dealing maybe with adverts, when we are dealing with what we offer, and so on and so forth. So what you look out for is sources of variance. Of course, you get the variance between, this is a regression, then the error variance, then the total irrespective. Of course, it will have degrees of freedom. The regression, it's going to be 1 because you have 2 variables, x and y. And so 2 minus 1 is 1. These are 20. 20 minus 1 is 19. And of course, you get 19 minus 1 to get the 1 for the residue. This is the variance. You know, when we are computing the variance, we get the summation x minus x bar squared over n minus 1. So the numerator is what we call the sum of square. So this is a sum of square for the regression. And then this is a sum of square for the residue. And then this ms, whenever you see ms, the ms means variance. So you get the SS divided by the degree of freedom, then the sums of squares divided by the degree of freedom, and then you get the F. This F compares, the F distribution is what we use to compare any two variances. So you just get the variance of the regression and compare it to the variance of the error. You want to be able to see, is it the regression that kind of is bigger or it is the error? And so when you compare, this is the value you get, which you normally compare with one from the table. Now, because we are using software, we normally end up with what we call a p-value, which is the significance. And whenever a p-value is less than 0.05, remember we use 95%. So whenever this p-value is less than 0.05, then we can say that the regression is actually significant, which means we can use the regression to inform policy to make decisions. I've tried to jab them because I don't want to go through the cores and maybe keep you guys confused or whatsoever. But I'm going to finally explain the things you need to pick out of this regression. You can read more on the ANOVA, but that is what the ANOVA does. So you just look for this p-value whenever it is less than your level of significance, which level of significance is 1 minus your confidence level. So those are a lot of technical terms. How do you get the level of significance? If you choose to be 99% sure, that is your confidence level in your results, and that means that your level of significance is going to be 1%. If you choose to be 95% sure, then that means that your level of significance is going to be 5%. But whatsoever the case, I'm going to request that for the class, you can focus more on this, look at your p-value and read more about it to be able to acquaint yourselves with it. But that is what it means. But our interest in the class was on this here, which we call the coefficients. So this is our A, this is our B, or this is our C, this is our M. So we're ideally saying that our model is equal to tenure is equal to negative 27.667 plus 1.509. It's going to pop out times age. This is the model we are having. And so we are saying that this is our regression status. So that is the interest normally people have. Of course, you have to look at these levels of p-values to be able to ascertain the significance of the model you've run. And the idea of telling you to go and read about regressions and all that was to kind of put you in the mood or bring you to this, that whenever you analyze data in such a way, you have to look at the p-values or the t-statistics or the confidence levels, confidence intervals, to be able to ascertain that the variable is significant or not. But the ascertaining of significance or not is the same as we did here. You look at the p-value. If the p-value is less, it's the same as you can see, then you can say that that value is significant or the variable is significant. But can we first forget about these ones? And we first focus on this model. Can you be able to explain this model? Can you get a volunteer to explain this model? People, can you get a volunteer to explain what that would mean? This one here. Because from what we're interested in running a regression statistics to ascertain the effect of age on tenure, and then provide necessary recommendations basing on those findings. So let us do that and give the necessary recommendations. This is tenure is the Y. This is the, let me put it down here. Y is equal to C plus MX. So how do you explain the negative 27? How do you explain the 1.509? I'm waiting for a volunteer. I'm going to get back the other side. That is our model. I don't have anyone.
I can try.
Okay, you try.
I can see that tenure or age positively affects tenure, that an increase in age leads to increase in tenure
By what?
by around 15%, if it is in percentage.
Okay, so that's a good one. Now, this is our intercept. We normally know that the intercept tells us the value of y when x is equal to 0. Okay. Okay. We normally say that this intercept here, which we call the C, is the value of y when x is equal to 0. I've kept telling you that as we move further ahead in maybe more analysis, you're going to realize that people don't normally explain the intercept, because for many, it may not make a lot of sense, especially when you don't have categorical independent variables. So what normally happens is that people actually just kind of even forget about it. But for us here in class, we shall explain it, because we really need to know what the value stands for, what it means. So this value here would mean that when you're looking at a baby, ideally for a baby, someone who doesn't have any age, the tenure is negative, which doesn't make sense. That is why I keep telling you that for many of the reports or policy recommendation reports that come from analysis of data, the intercept is normally not talked about, because many times it doesn't make sense. Because so you're saying a baby cannot, it's like, because when you say negative, the tenure is negative 27 months. It ideally means that the baby cannot have access to the telecom. But I want to focus more on this, what Timothy was explaining, which is the age, or what we normally understand as our coefficient of the slope, which is the 1.509. This 1.509 is the dy dx. So it measures the changes in y whenever x does what? Whenever x changes. So what we normally say about it is we are going to come and say that an increment in age by 1 year, because age was measured in years. So we shall say an increment in age by 1 year like this is going to increase tenure by 1.51 months. An increment in age by 1 year excuse me, is going to increase tenure by 1.51 months, holding other factors respectively. Of course, by 1.51 months, on average, we normally add a word on average because regression measures the changes in one increment in age by 1 increases tenure on average by 1.51 months, or holding other factors constant, a reduction in age by 1 year reduces, because this is a plus. So the plus means that these ones have what you call a direct relationship. So an increment in age by 1 does the same the other side. So this relationship is positive. It's more like someone telling you that the dy dx, if I can try to illustrate that on, let me use this whiteboard. So it's more like we are saying what we know, the normal we know about y and x. So we are saying that dy dx, which is our d-tenure, the age, is equal to 1.50 something, meaning any change, when you see that d, it means a change. Any change in tenure is equal to 1.50, a change in what? In age. So this means that if the change in age is positive, a change in tenure is going to be positive. If the change here is negative, the change in tenure is also going to be negative. So that is what that means. So whenever you get a positive slope, that means that the relationship is what you call a direct one. But if you get a negative slope, it means an inverse one, meaning when one increases, one falls, but by the units that you have in place. So I hope we've got that. Have we got that? Yes. Okay, so we are going now to provide necessary recommendations. Let's begin with what we've just looked at. So we are saying that increments in age increase the tenure, meaning older people are likely to use the service for long, right? Right?
Yes.
So what kind of recommendations can you provide for this company? Let's just think outside the box. What kind of if older people are more likely to use the services for a longer time, what are some of the recommendations you can give them? People, how many are we in class? I hope I'm not with one other person. Okay. What recommendations can you give them? We can just think of, for example, we can say, basing on the fact that increments in age increase the tenure, they can try to make sure, they can start making sure that the services they provide are age specific. So they need to understand what do older clients need, so that they make sure that whenever they are providing a service, it is specific to what they desire or what they want most. So it's about understanding that you have this, as older people are the ones who use you for long. So you need to understand what are the things they need most, so to provide them. And then also they can use the same to be able to pull the younger ones. So they need to ask themselves, why is it that the older ones are the ones who stay with us for a longer time? We need to go, and now they can do a market survey or a market research with the younger population and ask them, why don't you stay with our lines longer? What is wrong? What don't you like? So that they can still now be able to understand why younger people don't stay with the lines for a longer time, and then they still come up with policies or recommendations or interventions still that are age specific, so that they can pull both. It's as simple as that. So please don't now start thinking, because I saw someone, oh God, now where am I going to get the answer from? You just simply make a policy that is driven by what you have. So do we have a hand up? I'm very on, so if you can't hear me, it is a network problem on your side. But personally, I'm very steady. So maybe you check your network. If you can't hear me very well, it could be a problem on your side. But as I was saying, that the recommendation comes here. We are saying that increments in age increase tenure, meaning older people are more likely to stay with the telecom companies. So because of that, what recommendation? Number one, they can now go and understand the characteristics of older people. What do they desire from the company? What services do they use most? How do they like them? So that now they try to make sure that whenever they are coming up with services, they are kind of age category specific. Older people need more of maybe electronic banking or basic services. Then they can also use the same recommendation, because this means that younger people don't stay with this telecom company service for long. So they can now still go and carry out a market study or a market research with the younger ones. Find out, why don't you like our service? Why don't you use it for a long time? What can we do to improve it? So that still they can now come up with still age-specific interventions that they can increase their sales. So that is the recommendation. For the other one that was on tenure income, it's still the same. We can be able to see that those with higher incomes are the ones more likely to stay with the company for a long time. So they can now start trying to, you see the way companies work, these telecom companies. Let me just give you an example. You're going to realize that you could find that maybe most of the government agencies, or most of, let me say, the private agencies are using a particular network, because they're trying to say that maybe this private agency pays this kind of money, and we know that whenever money increases, people are more likely. So let us go and try to make sure that we advertise here. Or it's like seeing that you could find that maybe a particular telecom company could advertise on NTV and maybe not advertise. I'm being very specific, and maybe not advertise on Bukede, or not advertise on Delta, or not advertise, because companies look out for particular categories of clientele. Or you could find that, let's look at banks, for example. Chances are high that you're going to find that a particular bank advertises with a particular TV station and not all TV stations, because for them, they're looking out for a particular level of clientele based on what search findings tell them. So they look out for a particular kind of income group, kind of maybe category, and then they make sure that they focus more on that, because they know that these are the people who actually use our services. So they focus all their interventions on that particular category and not on everyone. That is why we are in shock these days that you find a bank that has very few clients but has maybe the highest kind of, let me say, turnover in terms of money, because they have a lot of money, because the clients, they get a few, but the money they put in is quite a lot. And then you find banks that have many people are depositing 100,000, they withdraw it the next day, then they take it. So that is how we come up with policy recommendations. Okay, so can we now continue on to the last one? There is no question. So the last one is saying that in a new sheet named clients long, filter out the clients who have been using the service for 48 months and above. In a new sheet called clients so long. Please put your question in the chat box. I'll be able to find it there. Someone was putting up the arm. So in a new sheet named clients long, filter out the clients who have been using the service for 48 months and above. What are some of the characteristics of such clients that are helpful for the telecom company and can be used to improve the clientele and make better marketing decisions? What recommendations can be made to management based on the analysis of those characteristics? So I want you to first read the question very well, because this one we're going to work it out together. In a new sheet called clients long, filter out the clients who have been using the service for 48 months and above. What are some of the characteristics of such clients that are helpful to a telecom company and can be used to improve the clientele and make better marketing decisions? What recommendations can be made to management based on the analysis of those characteristics? Okay, so let us move to our data. So we are using our sheet 1. This is our original. We are going to filter out clients who have been with the service for 48 months and above. But because the questions that follow are telling us that please make sure that you understand the characteristics, because they're saying what are some of the characteristics of such clients that are helpful, and then what recommendations can you make. So we are going to filter out. That's the first thing we shall do. Then we are going to discuss the characteristics of such clients that we believe are helpful for the company. Then we are going to make recommendations. But of course, before we make the recommendations, we are going to do analysis to understand, are they mainly female or male, those clients? Are they mainly short or tall? Are they mainly maybe aged or young? Are they made? So those are some of the things we are going to be able to do. And then we shall move on. I wanted us to be able to do cross tables, and I believe we are going to do them. So let us finish with this, and then we can do cross tables. Or let us do 2 cross tables, and then we come to this question. Let me set a question here on how many customers use basic categories, use the basic service, and are males. I just want to put it here before the other one. So let's, based on this question, to be able to look at something that maybe we could have left out, but it could be important. Everything is important anyway. So determine the clients that use the basic service customer category and are males. Determine the clients that use the basic service customer category and are males. So when we come to our data dictionary, the basic service customer category is here, and then the males are here. So one key thing you realize is that these specific categories are falling under these variables. One is under gender, one is under caste category, which means that if we want to be able to determine the number of clients that use the basic service and are males, we are going to have what you call a contingency table. It's a row column table that is going to it's a frequency table that is by row and column, because there are 2 variables that are categorical. One variable is going to be the row, and then the other variable is going to be the column, and then we shall tally or do what you call the count, and then ascertain that these are the males that are using the basic what? The basic service. Have we understood that? Have we understood that?
Not yet, madam.
Okay. I want us to look at this question. Are you looking at the question?
Yes.
So the question is saying, determine the clients that use the basic service customer category and are males. So ideally meaning how many, let me put the word number so that it doesn't maybe confuse a lot. How many clients or how many customers are males and use the basic service customer category, or and use the basic service? How many clients are male and use the basic service? Have we got that?
Yes.
Yes.
So the moment we understand that, now we come up here in our data dictionary and we ascertain, where does the basic service fall? The basic service falls under the caste category, which is a variable customer what? Category. And the males fall under the variable what? Gender. So for us to be able to ascertain how many basic service customers are males, it means that we have to make a tally of the males that use the basic service. Now in Excel or in statistics, when we have two variables that are categorical in nature and we need their frequency distribution, or we need a frequency table for them, it is normally what they call the contingency table statistically, but it is what they call a row column, row column table. Now that row column table, one variable becomes the row, and then the other variable becomes the what? The column. In simple terms, if you can be following me as I'm working this out, in simple terms, what normally happens is that you can have one variable like that, and then you can have the other variable. Then you can have the other variable in such a manner. So one is row, the other one is column. So what happens is that you now start counting how many are male and female, maybe 2, maybe 4, maybe 6, maybe 7, maybe 8. So this kind of presentation where one variable for any two categoricals comes as a row variable, and then the other variable comes as a column variable, is what we call a row column table, or what we understand as the contingency table. So how do we ascertain that? Our interest is just here. The interest you have in the question is just at that point, right? Our interest is just here, only there. But then we know that at analysis, Excel is going to give us even these other ones. But for us, we shall be interested in that, because here in the question we are having, they're asking us that the number of clients that use a basic service and are males. So follow through with me so that we can work that out. Let's go to our sheet 1, to our original sheet. I hope we are there. To be able to come up with a frequency table, at least I believe you now recall where we get that from. We normally get the frequency tables from the pivot tables. So please never forget that we get them from our pivot tables. So let's come here, come to insert, be anywhere within your table. I believe that you know. Then insert a pivot table. Let it select the entire thing, the entire range, as we say, and then say OK in a new worksheet. So when it says OK in the new worksheet, rename the worksheet to gender first cut, because it's the one we are using for that question. Or you can even rename it as question H. If you feel it's a lot of the words are too many. Now we are analyzing two, gender and customer category. This is just for purposes of you guys' presentation. They normally emphasize that for better presentation, you may not use this because it's not like a hard to fast rule. For better presentation, the variable, if you're having any two variables and you're going to draw a table for them, a contingency table for them, for better presentation, what you do is you make the variable that has more categories your row variable, because when you make it a column, it may not look as good as it looks when there are rows. This is just for better presentation, but this depends on you. Some people prefer it the other way around. So personally, I prefer having the one with more categories as the row. So you pick the customer category, put in the rows. I believe we can do that very easily. Pick the gender, put in the columns. Okay. Choose either of the two to have as your what? As your values, because it's about the count. So pick either of the two to have as your values, and then the values should come. Okay. So that is the table. Now, if you want to know the males that are using basic service, they are there too. Have you managed to do that?
Yes.
So now you would end up telling someone there are two males that are using the basic service. Of course, some of the key things you can point out from just this, you can be able to tell that females mainly use the basic and the plus service, and then the males use mainly the plus and the total service. Of course, you can be able to tell that the electronic service is not so commonly used. It still even takes up a 3. Majority of the people, or most of the people, the highest proportion uses the plus, and many other different aspects. So please take note of that. I'm going to request Timothy that you tell your colleagues that I'm going to re-forward you that link so that they can easily open it. If they keep on sending me, I'm going to get like 100 mails, and I might not be. So let me resend the link so that they don't face issues opening the recording. Okay, so that's how you. So anytime you're dealing with analysis of variables that are categorical in nature, and you're interested in their count or their frequency or their percentage, you use the pivot. So you make one the row and the column. You can have actually many, because you can count. You can even add the retired here, down here, so that they tell you that those using the basic service and maybe they're non-retired. So you can realize that for this we have only retired. Let me remove this and add a field that, let me say residence, to see if it has a yes, no. So you can be able to tell that those using the basic service and are coming from the peri-urban are 2. From the urban they are 2. You can be able to do quite a number of analysis basing on that, to be able to still make the same or similar conclusions, because what you realize is that the females and males from urban take up the same proportions, especially for those using the basic service. So you can add more levels, but still of categorical variables to be able to continue with more analysis. But our interest there was on 1. Okay. So, Madam, what's the importance of the p-value? Let me answer some of these questions. Statistically, we have 2 branches. We have descriptive statistics and inferential statistics. Mainly for policies, recommendations that are statistically driven, we get the descriptives to help us understand the point estimates and all that, but then we go further to do the inferentials, to be able to make deductions of populations basing on samples. Now, for you to be able to make such deductions, you definitely need what you call a probability kind of level. That probability level in inferential statistics is what they call the confidence level. So people commonly people are 90%, 95, 99, but you can have any kind of level of confidence that you desire as a person, because there are people who prefer to be 80%. But of course, it is always better to make sure that your results, you have high levels of confidence in your results. So when it comes to what we call a p-value is the one we use when we want to ascertain, or when we want to confirm, or when we want to be able to make conclusions on our hypothesis. Because in inferential statistics, we normally have hypotheses. It's divided into 2, estimation and hypothesis testing. So you can make a claim on your population proportion or your population parameter or anything, and you're like, I think the BACON students are very active in class. That could be your claim. But when you get into the actual collection of data, you could find that maybe they are not, or they are. But for you to make the decision that they're actually active in class or they're not active in class, you make that conclusion based on a p-value. Which p-value you compare with the level of significance. And that level of significance comes from your level of confidence. So if I am 90% confident in my results, it means that my level of not being confident is 10%, which 10% translates into the level of significance. Now, the p-value, because in hypothesis testing, we have 2 hypotheses, the null and the alternative. That's what I would want you to read, because now I'm in a class of inferential statistics, but let me give you a glimpse that maybe you can appreciate a little. In the class of inferential statistics, when I have my level of significance which comes from my level of confidence. I'm 90% confident. It means that my level of not being confident is 10%. That p-value is the one that would give you the probability of obtaining like results that are as extreme as the ones you would get when you ideally observe results from what you're computing or from the hypothesis you're analyzing. Of course, when you assume that the null hypothesis is the correct hypothesis. Because when you set a claim that the students are active, it means that there is another side of the claim that the students are not active. So one becomes your null, and then the other one becomes your alternative. The null is normally what you call the status quo, and the alternative is normally the reverse or the opposite of the null. So the p-value is compared with the level of significance. And whenever that p-value is less than the level of significance, we always reject the null hypothesis and we take the alternative. However, if it is not less and it is greater, then we just go ahead and say that we are failing to reject, or some people say accepting the null hypothesis. So in simple terms, the p-value is what allows us to say that the model is significant, this variable is significant, the relationship between x and y is significant. You know, sometimes you could say that there is a relationship between economics and statistics. But then you could find that now when you go into the inferential statistics, that could come at point estimation, where you compute your correlation coefficient, you get it at 0.4 or 0.9. Now, when you go into the inferential, adding a confidence level, you could find that actually the p-value is not significant, which would mean that that relationship is there, but it is not significant, meaning in simple terms, it's like it is actually not there. It could tell you point estimation that it is there, but statistically at 95, it doesn't exist. That is what that means. And then, Madam, how did you generate the equation of tenure and age? To be able to generate that equation, this is what we did. You come So to be able to estimate or generate that equation, these are the coefficients here. These are the coefficients. These coefficients are the C and the M. So this is the intercept, which is the constant. This is the slope. This is the coefficient for age, where remember we said that tenure is equal to, tenure is y is equal to C plus mx. So C is the constant, which is the coefficient here. And then M is the slope, which is the coefficient here. So that is where we got those coefficients from. Okay, so now let us finalize with the last question. I think the H lookup we shall look at next time when we introduce theta. Yes?
What we have done, is it the same like a cross tabulation?
It is the same as a cross tabulation, actually. It's a cross table. In simple terms, cross table, contingency table, it's the same, more column table. So this is a cross tabulation, actually. Let me remove this. That's a cross table because you have one variable moving row-wise and then the other variable moving column-wise. So it's kind of a cross. Yes, Timothy, it's a cross table. So we are going to now continue and look at the last set or the last piece. So in a new sheet named clients long, filter out the clients who have been using the service for 48 months and above, and then let us finalize with this. So let us come to our data. Control A, because we don't want to tamper with this original data. Always try to make sure that your original data stays intact. I am hoping you're saving, because saving is really very crucial. So Control A, be anywhere within your data, Control A, and then Control C. If that gives you a problem, do the normal highlighting that you would prefer. But the other one would be better, especially when you have big data. So Control A, Control C. Have we copied?
Yes.
Add a new sheet. Add a new sheet and paste that data. Have we pasted the data?
Yes.
Okay, now what we are going to do is we want to filter out the clients who have been using the service for 48 months and above, meaning our filtering variable of interest is which variable? The variable what? It is a variable what?
Tenure.
Tenure. Because tenure, it is the one in our data dictionary that tells us the months with service, okay? So it's our filtering variable. So we want to be able to pick those who have been using a service for 48 months and above. I hope you guys are with me. The filtering is one of the easiest things that you can do. So this one here, I don't expect anyone to have issues. There are two ways you can do it. We are going to begin with the menu, and then we can come and use. So one is you can come at home. There is, at the extreme end of the tools we can use at home, there is an editing kind of cell which has a certain filter. Are we there?
Yes.
So click on that drop down. There is like a small arrow that is dropping down. Click on it. Have you clicked on it?
Yes.
Click on the filter. So when you click on the filter option is going to pop up. It's going to show. Okay. Okay. I hope yours has the filtering option. Yes.
We have it.
You have it. Mine is not showing, but I'm going to make sure it does show. Okay, you have it. So let's use yours. I don't know why this isn't activated, but nevertheless, this can't fail us. Now, when you look at that, there is a drop down on tenure, right? An arrow that drops down, right?
Yes, madam. Yes, there.
Okay, so we are going to be able, see if this will work for me. What we are going to do is now we are going to be able to, let me first save and close and reopen again and see. Okay, so please go to that filter option. It doesn't make sense if it's not showing. Some people won't follow.
Mine is not active, madam.
It should be active. But others, you have your filters active?
Yes,
Yes.
madam.
So when you move to the filter options, you can be able to see filter greater than, right?
Yes.
Put greater than 48. I think we shall start from there if mine is not showing as well. Put greater than 48.
Madam, I beg your pardon. Where should we put greater than 48?
Okay. Now, if the filter drop down comes up here, you're going to be able to see all the numbers somewhere down there, but there is something called number filters. When you click on that car drop down, have you seen the number filters?
Yes, madam.
When you look at number filters, look for greater than, because in our question of interest, which is here, they are telling us that who have been using the service for 48 months and above. So it is greater than or equal to. Have you seen that option?
Yes, madam. I can see it.
So you go to that greater than. You go to that greater than or equal to. and then you put 48.
And we say okay.
Pardon? And then you say okay. Have you now seen that it has filtered?
Yes, it has filtered.
Okay. So now, what are some of the characteristics?
One of the characteristics I'm seeing that majority are coming from urban areas.
Majority are coming from urban areas, right? What
The
others?
majority are married.
Majority are married, right? What others?
Half are female and half are males.
Half are female. So I hope you're making the analysis on that. So now, those are some of the ways we can analyze. I'm really so sorry. Mine, it's active, but it is not working at all. So let me try to copy it somewhere else. The editing option is the one that isn't active. What do I do? Let me try to delete sheet rows. Okay, it's generally not active, so I don't know. Okay, some of them are active. But anyway, that is what you do. So we shall start from there so that I maybe other people who have not seen can be able to see. My cells editing and styles things is not active. I'm wondering why, so I'm trying to check it out to see. So people are basically getting the information. So now you understand. I'm going to request Timothy to be able to share his screen. Are you still using a phone and a laptop? Timothy. Okay, what of HTD? HTD, are you using a phone and a laptop? Or you're on a laptop?
Yes, madam.
You're using a laptop?
I'm using a phone and yes, I'm using a phone then a laptop. Yes.
So who is on a laptop and can share the screen on their laptop?
I can share my video at least.
You can share a video. Okay, so let me stop presenting. Please share your video. I can speak as you're sharing, so that we don't miss out.
Then after that, madam, I have a question, an inquiry.
Okay. HTD, please share your screen.
I don't know if it is clear enough. Maybe let me switch on my light.
For you guys who have laptops, why don't you connect data on the laptop and then because it makes it easy. I can follow up. I can be able to see because the phone and the laptop.
We are going to do it next lecture.
You'll do it the next class, because it's not so.
I don't know if it is clear.
It is not so clear. But that is the general outlook of the information that we've been working with. So the filter pops up, and the variable that you've used as the filtering variable is the one that will have that small, what is it called, a funnel, a funnel to ideally show that you filtered out something. Other variables will have the drop downs, but not the funnel. But the variable that you've based on to be able to filter will always have the funnel on it, to show that this is. And where you're seeing these numbers at the extreme end, where we have the numbers that we normally say A1, A2, A what, the raw numbers, they are blue in color. Now, whenever they are blue in color, it shows that that is filtered data. As you can see at the extreme, they are blue. Of course, you can be able now to understand the characteristics of those people, and then you can be able to make any policy recommendation. So maybe I think for our next class, let us begin with that, because the most important thing is knowing how do we now based on this to be able to go forward. So Jambo is saying he's only having 4.
I think for those who are having 4, they didn't put equal or greater than.
If you're having 4, you didn't put that greater.
Because you say that we should put equal or greater than 45.
48, because they said for 48 months and above. So it's very important to know that it is from 48 and above. So you can remove the filter, or Jambo. You can remove the filter by clicking on that and unchecking the filter, and then you rerun it again. You rerun it again to include the equal sign. You can rerun the entire thing again to include the equal sign. Okay, so this is what I'm requesting that we do. Let me first this is what I'm requesting us to do.